This is a go-to method. I like to call it log and lasso. To be able to log and lasso, you need to begin by making sure the power is alone. A power has a base and it has an exponent. In this case, the base is 5 and the exponent is -10 plus 3 to the x. Maybe there's a plus 7 off to the side of that and you'd need to subtract 7 to get the power alone. But since the power is alone, we are ready to log and lasso. Whatever I do to one side, I do to the other. So I'm going to apply the log to both sides. The exponent is in parentheses, even though we don't see that. So I'm going to lasso the exponent to the front. I call it log and lasso because I think of it like a cowboy sitting there riding a log, and then he throws his lasso up there to the exponent and yanks it to the front. So I took the log and then I'm lassoing that exponent to the front. Now that I've moved the exponent to the front, we've really accomplished a big thing. The variable is no longer trapped in the exponent spot. We can now just undo the order of operations to get x alone. So I'm dividing both sides by log of 5. Log of 5 is just a number. Then I'm going to continue to get x by itself by adding 10 to both sides. We still want to get rid of multiply by 3, which technically we're dividing both sides by 3. But because there's so much going on the left side, I think it would look nicer rather than dividing by 3 to multiply by a third. So I'm going to multiply both sides by a third. On the right side, those 3's would cancel and x is alone. I could pick up my calculator right now and go ahead and enter in that left-hand side, but instead I'm going to distribute the 1/3 through. So multiplying the 1/3 times that first fraction, numerator times numerator, denominator times denominator, and then 1/3 times 10 is 10/3. Grabbing my calculator, I found the answer to log of 3,125 divided by 3 times the log of 5, giving me 1.6 repeating, plus 10 over 3, and I end up with 5.